Welcome to XZ Energy by HMS Networks. This tutorial will show you how to publish data to the cloud securely from the SG Gateway using OPC UA. The steps are divided into 3 video parts, and this final part explains publishing to the Microsoft Azure cloud. First, we need to understand what the publisher contains before we compile it. This publisher is also an OPC UA client and an OPC UA server. Its client is connecting to our SG Gateway's OPC UA server, and its own server is used for isolated configuration injection, done by an OPC UA client tool like Process OPC UA client, for example. The accepting of the certificates on publisher's modules side must be done manually once, by moving files from rejected folder to accepted folder. Now we proceed with Microsoft Azure to publish data from the SG Gateway to the cloud. First, we create a new IoT Hub and name it My XZ Hub. After creating, click the buttons Go to Resource, Shared Access Policies and IoT Hub Owner. Then copy the connection string to clipboard for later. Back to local machine, compile the OPC Publisher by .NET Core SDK. Alternatively, you can use Docker as well. The sources for building the OPC Publisher are available on GitHub. Use the Windows command line to start the build process, as shown here. After compiling has finished, create a new publishednodes.json file in the shown subfolder next to the build DLL file. The template text from GitHub, see sources below, can be copied into the file and must be modified with the SG Gateway's endpoint URI and the OPC node we want to publish. The OPC node ID can be found in an OPC client like Process OPC UA client that is connected directly to the SG Gateway's OPC UA server by watching the data point details. The second part of the video shows how to do this. Now we are ready to call the DLL file we have built before, to initialize the OPC Publisher with our IoT Hub connection string from clipboard. Windows Firewall might pop up, asking for permission during the process. As the command line shows us, the OPC Publisher can connect to Azure Cloud already, but user credentials of the SG Gateway's OPC UA server are still missing. So first, we connect our configuration client tool to the configuration server inside the OPC Publisher by trusting each other. Second, we inject the missed credentials into the OPC Publisher's client for password authentication. Third, the SG Gateway's OPC UA server certificate must be trusted on OPC Publisher's side. Let's go through this step by step. The endpoint URI that is needed during the process is shown in the command line window. First, the client tool must accept the self-signed certificate of the OPC Publisher's server. The configuration server does not trust the client's certificate either, so this must be done manually by moving the certificate to the trusted folder as suggested on command line. Now it works. Second, create another new text file for configuration by using the template given on the Microsoft Docs site, and modify this by entering the connection data and login data of the OPC UA server. Then mark all and copy it to clipboard. Next, call the method IoT Hub Direct method with the input value published nodes and paste the text from the clipboard as input value of request.json. Now, the publisher's client can access the SG Gateway's OPC UA server, but the certificate of the SG Gateway's OPC UA server also needs to be trusted on publisher's side. To archive this, we have to move its certificate manually to the trusted folder. The local part also works fine and secure now, so we can start publishing to Azure Cloud. Start Azure PowerShell in the browser and create a storage. Then insert and execute the following two commands that you can find on GitHub. The setup is ready. Time to publish a simple constant value mapped to our output for publishing. The value is now displayed on the command line as it arrives safe and secure to Microsoft Azure. Great! Thanks for watching. You are very welcome to watch out for more videos.